morning everyone. Welcome to a2z Physics and Chemistry. Today we are going to discuss about very important part of class 12 students. This is potential energy due to a system of charge. We have to calculate here potential energy due to a number of charge. Okay. So first let us consider Q1 and Q2 are the charge. Okay. Let us consider Q1 and Q2 are the two charges which are located at R1 and R2 from a given position. Okay. Let us consider two charges Q1 and Q2 which are located at position R1 and R2 from a given location, or from the origin also we may take also. Okay. Now as we have to calculate the potential energy due to a system of charge, that means here we can calculate the net work done first, because we know the amount of work done in bringing a charge from infinity to a particular position represents the potential due to that charge. Okay. As initial first, let us consider we have to take Q1 from infinity to R1. Okay. As in this case no other charge is present around it, so the net work done will be equal to 0 in this case, or the net work done is 0 in this case from making the charge Q1 from infinity to R1. But the potential will be equal to V1 will be equal to 1 by 4 pi epsilon 0 Q1 by R1. In this case the net work done will be equal to 0, but the potential will be equal to 1 by 4 pi epsilon 0 Q1 by R1. Okay. Now suppose these are the two positions. Suppose these are the two charges Q1 and Q2. Okay. Now suppose let us consider Q2 is the another charge, and we are bringing the charge Q2 from infinite to the position R2. Okay. So in this case the potential due to the amount of work done in bringing the charge from infinity to R2 is equal to Q2 times the potential at R2 due to Q1. Again repeating the very important statement, the amount of work done in bringing the charge Q2 from infinity to R2 is equal to Q2 times the potential potential on R2 due to the charge Q1. So we can write out this is V12 will be equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. This R12 is the position vector in between Q1 to Q2. So here we have calculated the potential due to potential of Q2 due to Q1, which we have mentioned over here V12, which will be equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. Okay. Now we know here the work done, or we know that the net potential we can calculate by using the superposition principle. So individually we can say now this will be equal to, this will be equal to 1 by 4 pi epsilon 0, and there is Q1 by R1t plus Q2 by R2t. Now let us consider another charge. Okay. So as this is system of charge, we cannot include only two charges, but we have to take more than two charges. Now suppose this is Q1 and this is Q3. Now this is suppose Q2. Now this is Q12, this is Q13, this is like that. So this is R12, this is R23, and this is R13. The position vector are R12, R13, R23. Okay. Now we have already calculated the potential due to charge Q1, and we have already calculated the potential due to Q2 or on Q2 due to Q1. Now we have to calculate the potential on Q3 due to these charges Q1 and Q2. Okay. So in this situation what happens? We know the amount of work done in bringing the charge bringing the charge Q3 from infinity to the location R3 will be equal to Q3 times the potential at R3 due to Q1 and Q2. That can be written as Q3 into V12 will be equal to here 1 by 4 pi epsilon 0 Q1 and this is Q3 by R13 plus this is Q2 Q3 by R2 3. Okay, so first we have calculated, as we have taken first initially the charge Q1, so the net potential will be equal to 1 by 4 pi epsilon 0 Q1 by R1. Next we have calculated the potential on Q2 due to Q1, which is V12 will be equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. Next we have calculated the potential on Q3, which is equal to the or we can say Q3 multiplied by the potential due to 1 and 2, which we can calculate. This is 1 by 4 pi epsilon 0 Q1 Q3 by R13 plus Q2 Q3 by R23. Now the net potential due to this system of charges will be equal to, now we can calculate, this will be equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 plus Q1 Q3 by R13 plus, here also mention about here, this is Q2 Q3 by R23. Again repeating this, as this is very important one. First we have taken three charges, and for the first charges the net potential is Q1 by R1, but the net water will be equal to 0. Okay, now secondarily here we have net water which we are calculating. Next we have calculated the potential due to the charge Q2 due to Q1. Okay, next we have calculated the potential due to Q3, and this will be equal to due to Q1 and 2, and the net potential energy will be equal to, in this case, or water will be equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. As we know, in this case the potential energy is stored in the form of the free water is stored in the form of the potential energy. So we can write down this water as the net potential energy, which is equal to 1 by 4 pi epsilon 0 Q1 Q2 R12 plus Q1 Q3 R13 plus Q2 Q3 R23. Okay. Let me explain this same potential energy due to a system of charge by using a example actually. Let us consider one example. So, for calculating the potential energy, let us consider a square having charges Q, and there is minus Q, at the corner, and suppose the distance between them is D. Now, initially we are taking the charge Q, and the water will be equal to how much? This initially this is 0, because we know that initially as we are taking Q and there is no surrounding charge present over here, so the net water will be equal to 0. Now for second Q, this will be equal to 1 by 4 pi epsilon 0. This is minus Q into Q by D square. So this will be equal to 1 by 4 pi epsilon 0 minus Q square by D square. So we have also calculated the water on W2. Now the water on W3 is important. W3 will be equal to, this is 1 by 4 pi epsilon 0, and this will be equal to, we know this is W3. Suppose the water in this Q will be equal to W3, then this is, there is a 1 Q over here, so this is minus Q square by 4 pi epsilon 0 plus there is another one, this is also Q square, and this will be equal to, in this case, or there is here also D, because the distance between them is D. Now in this case this is 4 pi epsilon 0, and this is D, this is D. So this value will be equal to, this is D square plus D square root over. So this is, we can say D square plus D square. As this we are using the Pythagoras theorem, so this is D square plus D square root over. So 2D square root over. So we are getting this root 2D. So this value will be equal to root 2D. So here we have, this is root 2D. Okay, so the water on 3 will be equal to 1 by 4 pi epsilon 0 minus Q square 4 pi epsilon 0 Q square by 4 pi epsilon 0. This is root 2 into D. Okay, now the water due to the charge 4 will be equal to W4, and this will be equal to 1 by 4 pi epsilon 0. This will be equal to, now due to this is minus Q square by D plus, due to these two, this is also minus Q square by D. Now plus, this is due to this will be equal to Q square by root 2D. Okay, so we have got 4 work, W1, W2, W3 and W4, and we have to calculate the net by adding all of this. So we can now add this W1 plus W2 plus W3. So W will be equal to W1 plus W2 plus W3 plus W4. Now this will be equal to 0 plus 1 by 4 pi epsilon 0 minus q square by d square plus W3 with the value will be equal to how much? This is 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0. This is minus q square by 4 pi epsilon 0 d plus q square by 4 pi epsilon 0 d root 2. Okay? Plus now q to W4. This will be equal to 1 by 4 pi epsilon 0 into minus q square by d, and this is plus q square by d. So there no need to write down this. This is because they have cancelled out each other. So this will be equal to q square by root 2d. Okay. So now we are getting how much the value? This w will be equal to, in this case we can common 1 by 4 pi epsilon 0. Again here there is a minus q square by d. Here also there is minus q square by d. Here also minus q square by d. So here we can take q square by d as the common. Okay. Now this is minus 1 and plus, that is here also again minus 1 because there is a minus 1 over here. Then this is 1 by root 2. Okay. And there is also plus 1 by root 2. Okay. So the value will be equal to, in this case, W equal to 1 by 4 pi epsilon 0 d, or we can say q square by d into minus 2 plus 2 by root 2. Or if we taking 2 also common, so this is 2 q square by 4 pi epsilon 0 d into 1 by root 2 minus 1, and this is the final result. Okay. So how we have calculated? First we have calculated the water due to the charge 1. Then we have calculated water due to the charge 1. The water due to the charge Q2 due to Q1. Then we have to calculate the water due to Q3 or water on Q3 due to charge Q2 and Q1. Then we have calculated the water on Q4 due to Q1 and Q3 and Q2. And we have calculated all of this value and we have added to get the net work done in this case. And we know that this work done is now converted into a potential energy. So in this case we can calculate the net potential energy for the system of charge. Okay. So this was today, and I hope you all enjoy my classes. So do subscribe if you like my classes, and thanks for watching.